So we're going to take a couple days here and look at this next section, trigonometric equations. So you guys have been doing equations for a long time in math, and there's a lot of the same types of things with it, but now we got to look at things in trigonometry. Okay, so there's some similarities, there's some differences between them. Okay, so we're going to start nice and slow with this guy here today just to get the idea of it so we can get a lot of work done in class tomorrow. So in algebra, we've always encouraged you guys to check your solutions. Okay, if you think 10's the answer, go plug it in, and both sides better be equal. Okay, you can do the same thing in trig, and you can make sure these things work. It's just a little bit tougher, and you have to have an understanding of the unit circle. Okay, so you guys have seen questions like this: is x equals 4 a solution to whatever? So all you would do is you'd say, okay, well, it's a yes/no question. I'm going to go plug a 4 in. Okay, we can clearly see that's not equal to 37, so we'd say no. Okay, and you guys can use everything you've learned in Algebra 2, College Algebra, and you could actually solve this. Okay, so some equations have one solution, quadratics have two solutions, cubics have three. You guys have done polynomials with 4 or 5 solutions, maybe some are complex. Okay. The other thing we can look at, so I can ask you a trig equation. So I can say, is theta equals pi over 3 a solution to cosine of theta equals 1/2? So it's still a yes/no question, but it's different than the algebra we're used to. So we're going to take this, we're going to throw this guy right in here. We're going to say cosine pi over 3, which you guys know is cosine of 60 degrees. So I want to know if that's 1/2. You guys can use your unit circle, but it's good practice just with these triangles as well. If that's the 60, that means there's your square root of 3, 2, 1. Cosine of this, 1/2. So yes. So we're gonna be looking at a lot of stuff like that, but you can check the solutions you get. Okay. Now, if I tell you this, sine of theta equals 1/2. Okay. We could do an inverse here. We could find where it actually is 1/2, or I could say find all the places where the sine is 1/2. We've looked at a unit circle from 0 to 2 pi. Okay, signs are going to be positive, quadrant 1, and quadrant 2. And then we can actually get these values. So this happens at 30. This is 30 as well. But the big angle here is 150. So sine theta is 1/2 at 30 and also at 150. Now, if I don't restrict this domain, okay, meaning inverses, we have restrict the domain. So we said sine inverses only happen here and here. Okay. If I let it go 0 to 2 pi, well, we can now look at all 4 quadrants. So if I let this thing go around and around and around again, I could say sine of theta equals 1/2 at 30 degrees, at 360 degrees, okay, because we're just going to, not 360. How about 390? Take the 360 and add the 30, okay, and I could add another 360 to it as well. So I could say this also happens at 750 degrees. Okay. I can also say sine of theta equals 1/2 at 150 degrees, 510 degrees, and 870 degrees. And these things keep going. Okay. If I let this just spin around and around and around. So we need to have a way to represent those. Okay. We did them in degrees here. We could easily change those guys to radians as well, which is how you're typically going to see your answers. Okay. So a few things we're going to look at. I want you to give a general formula to find all the solutions for this guy right here. So I'm not necessarily asking for all the solutions. I'm asking for the formula. Okay, so we're going to start with that, and then we can actually evaluate the formula to get some solutions out of here. So I'm saying cosine of theta equals 1/2. So I think about it. Cosines, we're not worried about inverses here. Okay, just so where is the cosine 1/2? Okay, we have an unlimited domain for this. It's got to be in quadrant 1. Okay, and it's also got to be in quadrant 4. So here's the 1, here's the 2. Now that means this is your square root of 3, this is your negative square root of 3, so this has got to be 60 degrees down here. Okay, so the 30's got to be up here as well. So where is the cosine 1/2? Well, it's going to happen at, and I'm going to do this all in radians, pi over 3 plus every time it spins back around to it. So last time we looked at them in degrees, okay? But get used to doing these in radians because it's how you're going to see these. So I'm going to say it happens at 60 degrees, which is a third, plus 2 pi times k. Now we looked at that k before last week when we did those problems. All k is just any integer. So we started it as 0. If k is a 0, this whole thing goes away, and we're at the pi over 3, which is exactly what we wanted. If the k is a 1, well, it happens at 60 degrees plus another 360, so it happens at 420 degrees. We can convert that to radians, or you can add 2 pi to the thirds, and we'll look at that in a little bit. Now, that's not the only place that this happens. Also happens down here in quadrant 4. Now before, when we did inverses, we always did this guy negative. Okay, so there's one way you can do it. So this guy right here is going to be a negative 60. So we can say it happens at negative pi over 3 plus 2k pi. If the k is a 0, it happens at negative 60. If the k is a 1, well, it happens going around once and then going around another 300 degrees. There's one way you can say it, or you can say this. Now, depending which ones you start with, your first solution is going to be different than somebody else's, but it's going to keep the same constant ratio. So these guys here are equal. So you definitely have to give me this one. Okay, general formula. I'm not asking for the solutions, but this is a general formula to find all of them. So you have to give me that one, and then either one of these two. You can give me the first one, or you can give me the second one. They both convey the same things. It's a matter if you want to say the negative, or if you want to go all the way around to where this guy should be. Okay, so those are your general formulas. Okay, in the second part, we'll look at actually finding some solutions for these.